Let's talk about the third question, which says find the distance between P x1 y1 and Q x2 y2 when PQ is parallel to the y-axis, and second part PQ is parallel to x-axis. Okay, when the line segment PQ becomes parallel to x-axis or parallel to y-axis, you can maybe guess something about x1, x2 and y1, y2. Maybe you can get something related to that. How will we do that? Let's talk about this. The first part. For the first part, what do we have? PQ is parallel to y-axis. Okay, if PQ is parallel to this y-axis, let's say point P is here, point Q will be somewhere here. It can be here as well, but point P and Q will be in this manner, right? Point P is x1, y1. Point Q is x2, y2. And if this becomes parallel to the y-axis, you can clearly observe that x1 will be equal to x2. That's what you can observe, right? That is, since this particular PQ is parallel to the y-axis, the x coordinate will remain same, right? If the x coordinate is same, then distance of PQ, the length PQ, which is equal to under root of x1 minus x2 whole square plus y1 minus y2 whole square. We are simply applying the distance formula. This is equal to this. x1 minus x2 will become 0. Okay. And this is y1 minus y2 whole square. We cannot comment anything about this. This remains as it is. Okay. Under root of y1 minus y2 whole square. What is that? Under root of x square. And what is square root of x square equal to? Mind you, it is equal to mod x. Right? This is something which you should be aware of, which you should remember. It is not plus minus x, it is mod x, right? This value is always positive. This should be always positive, right? So this becomes y1 minus y2 and its modulus. Will not write it as plus minus y1 minus y2. This is it, right? If y1 is greater than y2, this becomes y1 minus y2. If y2 is greater, this becomes y2 minus y1. The final output that you will get over here by substituting any values of y1, y2 should be positive. Should be positive, non-negative, or precisely non-negative for that matter, right? This is what you have. So this is the first part when PQ is parallel to the y-axis, and now you can easily guess for the second part. What you'll have is, if PQ is parallel to the x-axis, what you'll have is, this is point P and this is point Q, let us say. If PQ is parallel to the x-axis, the coordinates x1, y1 and the coordinates x2, y2 will have a condition. What is that? If this is parallel to the x-axis, the y coordinate will be same. That is, y1 will be equal to y2. Here, y1 equals y2. This is the important thing. Therefore, PQ, the distance PQ is equal to what? Now, seeing this calculation, you can observe, yes, it will be modulus of x1 minus x2. But let's write again, x1 minus x2 whole squared plus y1 minus y2 whole squared and its under root. This is the distance. And that second term becomes 0. So this becomes under root of x1 minus x2 whole square, and which is equal to modulus of x1 minus x2. This is what you'll have. That's PQ for us in this second part. When PQ is parallel to the x-axis, this is the distance. Modulus is important. Modulus is important, right? The value has to be non-negative. Value has to be non-negative. That's the complete solution of this question over here.